Hello everyone, this is Om Godge and today I'll be solving lab 9. So the first question was insertion sort. In this question you are given an unsorted array of elements and you have to sort them in ascending order, and they have explained an algorithm to sort this. So the algorithm goes as such that, let's say you have an array and it is sorted by until now. So you have some elements. Okay, let's say you have 1, 3, 7, 9, 8. Okay. Nine, third 14 and 17. Okay, this array is sorted right now, and let's say you want to insert a new element into this array, which is 6. So as you see, 6 should go somewhere over here. So what you do is you check each of these elements one by one, you compare these, and when you find that when you find a number which is bigger than your current number, then you put it over here, and then you have to push all these you have to shift all these elements by one place and create a new area for the last number. So your size of the array goes by up by 1, and now this will be your new array. This is what insertion sort is. So the way you will solve this would be, you will start off with just one element. So let's take this first example. Okay, you have this. So the first element you had is 3. So 3 can be directly added into your array. So you have this, and you have 3 in your array. Now you read a 5. So you have a 5 outside. Okay, so to solve this, first thing you do is iterate over all the elements in the array, place the min element inside the array, carry the max element through the array, and then push back finally push back the max element at the last. Okay, this is not required. This is how you have to do it. So in this example you have 3 and 5. So since 5 is bigger than 3, according to the second point you will place the min element. So 3 is already in its right place, so you'll carry 5 over here. Now the array is over, so at the end you will push the max element into the array. So now you'll have 3 and 5 here because you pushed 5 in the vector, so it will come at the end. So you have 3 and 5. Now the next number that you have is 1, so you'll have a 1 over here. Now when you compare these two elements, since 1 is smaller than 3, 1 will be placed over here and you will have 3 outside. Then you take 3 and go over here. Now between 3 and 5, 3 is smaller, so you will place 3 here and you will carry 5, and you reach the end of the array. So you push the max element. So you will add 5 at the end over here, and now this is your new sorted array. Okay, so alright, so the next number you have is 6. Now when you compare 1 and 6, 6 is bigger, 3 and 6, 6 is bigger, 5 and 6, 6 is bigger. So the max element is 6, and you simply push it into the array again. So you'll add a 6 over here, and then finally you have an 8, so you'll have 8 over here. Now again 8 is bigger than all these elements, so it will go until the end, and then you'll add 8 at the end. And then you have the whole array sorted. Let me take this example. So if you have this, so the first element that you have is 5, so I'll put a 5 here, and I'll get rid of all of this. Okay, and then you have a 2 outside, so between 2 and 5, 2 is smaller, so this will be replaced by 2, and this will become 5 here. You reach the end. Now you push 5 at the end, so 5 goes here. The next element that you have is 8, so 8 is bigger than both 2 and 5, so it will simply be pushed at the end. Okay, now the next element you have is 6. So over here 2 and 6, 6 is bigger, 5 and 6, 6 is bigger, but over here 6 is smaller than 8, so you will put 6 over here and have 8 over here, and then you will push 8 at the end of the array. Then you have 12. Let me shift this over here. 12 is bigger than all the elements, so it will just be pushed behind. Then you have 4. So 4 is bigger than 2, but 4 is smaller than 5, so you will put 4 over here and have 5 over here. Then you'll go here. Between 6 and 5, 5 is smaller, so you'll put 5 here, you'll put 6 here. Then between 6 and 8, 6 is smaller, so you'll put 6 here and 8 here. Between 8 and 12, 8 is smaller, so you'll put 8 here and 12 here. And then finally you will push a 12 into the array. Oops. Okay, now you have 17. Now 17 is bigger than all the elements, so it will just simply be pushed at the end. Okay, now for 1. Now since 1 is smaller than all the elements, it will get replaced over here. Now you'll have 2 here. Now 2 will get replaced here, and you'll have 4 here. Then 4 gets placed here, you'll have 5. Then 5 gets placed here, 6, then 6 gets placed here, 8 gets placed here, 12 gets placed here, 17, and finally 17 is the biggest element, so it will get pushed at the end. And now you have the whole array sorted. So this is how the insertion sort algorithm goes, and that is what I've written in my code. So we start from here. You first input the first element and push it inside the array. The array first has a size of 0, and after pushing the first element it will have a size of 1. Okay, then you read n-1 elements because the first element is already read, and you take it as input, and then you call the insert function with array and num. So num is the number that you want to insert inside it. and finally you just print the array. Printing the array is pretty simple. Let me make it bigger. Okay, printing the array is simple. You just iterate over all the elements and print the number with a space, and then at the end you just do a new line. Okay, so the insert function, so as I said, you have to keep track of the max element which is there up to now, so that is stored in max. N is the size of the array, so you iterate over all the elements, and you take the max of mx and ri. So as I was doing here, like I had, what did I have? Okay, let's take this. So this is this that I'm moving around, this is mx, yeah, so this is mx, and currently this is I should put, yeah, this is fine. So this is mx, this is I, and then temp will store the max of mx and I. So in this case you'll have temp equals 17 because the max of 12 and ri is 17. So temp will store ri, then ri will store the minimum of both of these. So then ri will store 12, and then mx will become temp. So mx will now become 17, and then you don't need this, so you can delete this. So it will just swap these two elements if this number is bigger than this one. Okay, and you always have mx as the max element, and that mx gets propagated throughout the array, and you will insert mx at the end. So when you reach at the end, you will do push back mx to add the last element, as I did in my example as well. I added this guy here. So this is the pushback operation, and now you can get rid of mx as well. Now you can get rid of I as well. Yeah, that was the question. That's all. In question 2, you are given a Sudoku puzzle which is partially filled, like some of the elements are empty and others are filled with numbers from 1 to 9, and you have to tell whether the board is valid or not. So a valid board will contain the digits at most once, like each row, each column, and each subgrid. It will contain the numbers 1 to 9 at most once. It cannot have a number more than once. Okay, so to solve this, we'll keep counts of every number of how many times does a number appear in every row Okay, so we'll just keep a count of how many times each number appears in every row, every column, and every subgrid. So since there are 9 rows, 9 columns, and 9 subgrids, as well as 9 numbers, we'll have a 2D array to store each of them. So we'll have rows as 9 cross 9, calls as 9 cross 9, and subgrids as 9 cross 9, where row ij denotes that the number j plus 1 denotes how many times does the number j plus 1 appear in row I. So okay, the first thing is, why is this j plus 1? So since since array indices start from 0, so and this is 9, so this number j will go from 0 to 8, but your elements are from 1 to 9, so that's why row ij denotes the number j plus 1. So j denotes j plus 1 basically, because 0 to 1 to 9 is mapped to 0 to 8 when you store it inside this thing, this guy. Okay, so row ij denotes how many times does the number j plus 1 appear in row I. So let me take a small example to explain this. This is a simple 3x3 grid. Let me fill it up with some numbers. Let's say there's a 3 over here, there is a 6 over here, there is a 2 over here, there is a 1 over here, and the rest are empty. So we'll have a dot here, a dot here, a dot here, dot here, dot here. So this is row 1, or row 0 rather. This is row 0, this is row 1, and this is row 2. This is column 0, this is column 1, and this is column 2. Forget subgrids for now. Let's just focus on rows and columns. So for this case, row 0, 2 will be set to 1, because in the 0th row there is 3, right? So 3 is present once. So 3 is j plus 1, so j will be 2, and it appears once, that's why row 02 will be 1. And since there is no other element in row 0, all other elements in row 0 will be 0, because there is no other element. Similarly, row 1, 5 will be equal to 1, all other 0, and row 2, 1 equal to row 2, 0. Okay, I should have written 0 first. Row 2, 0 equals row 2, 1 equals 1, all other 0. This was for row. Now for column, you'll have col 0, 2 equals 1, all other 0. So now 0 denotes this column here. So inside this column you have inside this column you have a 2 and a 3. So I forgot to write that. You'll also have this as 1, and call 0, 2 as 1, all other 0. Then in row 1 you have 6 and 1, so you'll have call 1 0 equals call 1 5 equals 1, all other 0, and then there's nothing inside the third column or the second column, call 2, so you'll have call 2 will be all zeros. Okay, this is about the rows and the columns. So now let us see how will we calculate these for the subgrids. So I can just do this. Okay, so I'm just gonna create a and select all of these, shift. Okay, so now you have the whole Sudoku. This, this, this. God. Okay, fine. So this is grade 0. This is grade 1, this is grade 2, this is grade 3, this is grade 4, this is grade 5, grade 6, grade 7, and grade 8. So similar to row and call, grade ij denote how many times does j plus 1 appear in, okay, I should write subgrid here, in subgrid I, right? So how many times does j plus 1 appear in subgrid 0, subgrid 1, subgrid 2? This will be stored in subgrid ij. Now the tricky part is you can iterate over the rows and the columns, but how do you cleverly get the subgrid index? What I'm saying is that forget these numbers. what you can easily get the rows and columns. So what you can do is you can iterate, uh, you can have an index I that iterates over all the rows, and then you can have an index j, uh, that iterates over all the columns. So you'll get you'll get this index and you'll get the column index correctly. But how do you get the subgrid index? Like, how will you get 0 for this and 1 for this and 2 for this? That is what I've written here. So okay, I'll get rid of this part for now. I'll put this here, I'll put this here, and I'll put this here. This also I can get rid of. So how would you find that? So first, let's try to see if we can spot a pattern. So for subgrid 0, I and j take the values 0 0, 0 1, 0 2, I'll just copy this. Then you have 1 0 1 1 1 2, and then you have 2 0 2 1 and 2 2. So what I'm saying is, this is subgrid 0, right? This part over here. So this guy has these coordinates, like I is 0, j is 0. Then this guy is 0 1, this guy is 0 2, this guy is 1 0, this guy is 1 1, and so on. So I'm just seeing if there is a pattern that I can spot. So this is subgrid 0. Then similar to this, for subgrid 1, you have the rows stay the same, so the I values will stay the same, but the j values will change. So for subgrid 1, the j values will be 4, not 4, my bad, 3, 5, 4 and 5. Okay, and then for subgrid 2, you will have, again the I values will stay the same, but the j values will be 6, 7, 8. So convince yourself first that this is true. Like, these coordinates are will give me subgrid 2. So one thing you see is that from 0 to 2, the I values are the same, but the j values are changing, and the j values are changing on every multiple of 3. Like 0 1 2 all belong to the same subgrid, then 3 4 5 all belong to the same subgrid, and 6 7 8 all belong to the same subgrid. So you can see that j percent 3, I should, j percent 3 plays a role here. So if you see over here, j percent 3 is the same for all these. So if you take the remainder of, no, not j percent 3, my bad, j by 3. J by 3 plays a role here. So if you divide 0, 1, 2, all of them with 3, you'll get a 0. And that gives you subgrid 0. Because you're doing integer division, so there's no remainder over here. So 2 divided by 3 will give you 0. Then similarly, over here 3, 4, 5 when divided by 3, it will give you 1. And 6, 7, 8, all of them divided by 3 will give you 2. So j by 3 gives you the subgrid for the first first 3 subgrids basically. Okay, so j by 3, rather I should write j by 3 gives you the correct subgrid. Now let's further look at the other subgrid, the other part. So subgrid 3, subgrid 4, subgrid 5. So for subgrid 3, now subgrid 3 will have the same j values as subgrid 0, because this is subgrid 3 now, so all the j values will stay the same, but the I values have changed now. So the I values will be starting from 3. So you'll have 3, 0, 3, 1, 3, 2. Then you'll have 4, 0, 4, 1, 4, 2. Then you'll have 5, 2, 5, 1, 5, 0. This will be subgrid 3. Similarly, for subgrid 4 and 5 as well, the j values will stay the same as subgrid 1. So subgrid 4 will have the same j values as subgrid 1, but the I values will now become 3, 4, 5. 3, 3, 3, 4, oops, yeah, 4, 4, 4, and then 5, 5, 5. The same thing for subgrid 5 as well. This will just become 3, 3, 3, 4, 4, 4, and 5, 5, 5. Okay, so now you should notice that over here 3 plus j by 3 gives you the correct subgrid. So let's look at these numbers. Like if you add 3 to this guy, you'll get if you add 3 to 0, you'll get 3. What am I saying? J by 3 was these numbers, right? So 0, 1, 2 will give you 0, but this is 3, so you just add a 3 to this, and then 3, 4, 5 will give you 1 when you divide it by 3, and you just add a 3 to get 4, and then 6, 7, 8 which gives you 2, as you saw here. You just add a 3 in it to get 5. So j by 3 plus 3 gives you the correct subgrid for this, but there has to be some usage of I as well to get this formula. So now I'll just write the formula in general, and you can try to understand how you get that formula. So the formula would be 3 into I by 3 plus j by 3. This gives you the correct subgrid index. So as you see here, I was always 0 1 2 for the first row. Like over here, I equals 0 1 2. So I by 3, uh, I by 3 will always become 0 for this case. So this first term is useless for the first row. Only the second term matters, and that is why you only get j by 3 here. Now for the second row, for this row, I is taking values 3 4 5. So now here I by 3 will give you 1, so this will become 1, and you multiply 3 to it, so you will get 3. That's why 3 plus j by 3, which you wanted, will give you the right subgrid for these guys. And it holds the same for the third part as well. Like subgrid 6 7 8, this formula will give you the right values, the right subgrid indexes. You can try to verify it on your own and convince yourself that this formula will give you the right subgrid. Okay, so now it's very easy to solve, so I'll just show you the code directly. So you create these 2D arrays of size 9 cross 9, as I said, and you initialize all of them to 0. Put all of them to 0. They store the counts of each number, like how many times a number appeared in a row, a column, and I'll call this a subgrid. Okay, fine. So now you set all of them to 0 first, then one by one you read each cell which is in the Sudoku. So like you read 5, then 3, then 4, one by one inside cell. Then you check if the cell is empty or not. So if the cell is empty, you can just continue, no need to count anything. If the cell is not empty, then you find the number corresponding to the character. So this is a character, you subtract 0 from it, you'll get the number, whatever it is representing, between 1 to 9. Then you do row I, because this was the ith row, and then element minus 1. So you do element minus 1 to map 1 to 9, 1 9 to 0 8, because these indexes go from 0 to 8, but your element goes from 1 to 9, that's why a minus 1 is done. Yeah, that's all. So then you say that inside row in row I, element has appeared once, so you just increment the count, and in column J, element has appeared once, so you increment the count. Then inside subgrid this I by 3 into 3 plus j by 3, which I showed over here, like this gives you the right subgrid. In this subgrid, element has appeared, so you increment its count. So this way you count how many times a particular element appears in each row, column, and subgrid, and then you check if the row, the column, and the subgrid, if all of them are valid, like all of them satisfy these three conditions. These three conditions are satisfied, basically those conditions are checked here. Then you print true, otherwise you print false. So now let's look at what is valid is. So is valid just makes sure it takes the 2D array as input, and it makes sure that none of the elements are greater than 1, which is what you require. Like all of the elements should be present at most once. So it just checks that, and if any element is present more than once, then it will return false, otherwise it returns true. So that's how you check the validity of the Sudoku. And yeah, that's all for this question. The third question now is regular expression. So in this question you are given a string which has either letters, parentheses, or the raised to operator with a number uh, following it. So there are some examples here, and you want to print the pattern that you get. So a raised to 3 is just ab squared is abb, um, ab whole squared is just ab, and you want to print this final pattern. So to solve this question, first I'll start off with the base case. So the base case for this would be consider strings without any parentheses. So this is what you should do when trying to solve a difficult problem, is just look at a part of the problem first and try to solve that, and then build up onto that solution. Yeah, so using this parenthesis thing you can have a lot of. So the reason why I chose this as the base case, or like the simpler case, is because you can have strings like this, a b c a b c 2 3 maybe. So you can have something like this, and there are a lot of nestings of these parentheses, right? So that might be confusing for you at the first go. That's why you should start off by not considering parentheses entirely and just looking at strings of the form a raised to 4 b c d raised to 3 c cube a, something like this. So this is very simple to solve. Just iterate iterate over the whole string. If the current letter, the current character is a letter, append it to your answer. If the current character is this, then the next character gives you the repetitions, and the previous character gives you the letter to be repeated. So for example, let's say I'm trying to convert this string. So I have this, and the first thing I said was iterate over the whole string. So what you'll do is you'll have an integer I which goes from 0. I goes from 0 to string dot size or string dot length -1. Okay, and you are iterating it over it one by one whenever you see a letter. So now you have seen A. So what you will do is, firstly your answer will be equal to an empty string, and then after I equals 0, answer will now become just A. And then the next letter at I equals 1, str of I is a this raised to, or I'll call it hat for now. So the letter at index 1 is a hat. So what this means is that you have to repeat a 4 times, but you have already added a once, so you have to only add a 3 times into answer. So after reading in a hat, you will do repeat actually concatenate str I minus 1 int of str I plus 1 times, or rather you could do something like this. Yeah, so str I minus 1 is the letter and str I plus 1 is the number that you have. You subtract 0 from it because this is a character, and you convert it to an integer, and you repeat these many times, and then concat this string into answer. So you'll have a temp string that is just AAA, and then you will do answer equals answer plus temp. So then your answer will become AAAA. I'll put this over here. Okay, this is so now what you've done is you have reached here, and then this is over here. Okay, I hope you get the point. I'll just put an I instead. Okay, so your I currently is here, and then you have already passed this 4. So after this, what you can do is simply do okay, this is better. Do I plus plus as str I plus 1 is already C. So you already saw str I plus 1, so you just do I plus plus over here to move this arrow from here to here, and this moves here. Okay, and then your for loop will again increment I on its own, so your I will get incremented and you'll come over here on B. Then you'll do the same process. You will since B is a letter, you'll just add it to answer, so you'll just do this. So your answer will become AAAB. Then you go to the next letter then, and then you repeat the same thing. So you see there's a letter, so you will just add C into it, and then you go here, you will see there's a D, so now you will add a D. The next letter is now a hat, so you do this what you did over here. So you see the previous letter was a D, and then the next letter is a 3, and then okay, I forgot to do this -1 over here. So this -1 is because the letter has already been added once before, so you don't need to add it. So you only need to add it 3 more times over here. Similarly, over here you only need to add D 2 more times. That's why you will do this -1. Okay, so then you'll get your temp as dd, and then you do answer plus equals temp. So that will give you answer equals a b c d d d, and then you do I plus plus. So you will move this over here, move this here. Now your for loop will increment I on its own, so it will go to C. Then you add C once more. Again you see a hat, then you'll add C two more times into temp, and then add temp to answer. So you'll get 3 C's into the answer, and then you do I plus plus. Your for loop will again increment I. You will get to the last A. You will add A once to your answer, and then it's over. You have finished the string, so your for loop stops. And after that, you have the whole parse string into answer, so you can return that directly from your function. So that is the base case where there are no parentheses. Okay, now let's consider what if there are parentheses. So if there are parentheses, note that so let's take an example. So let's say ABC, and you have this. I'm taking a simple case where there is just one parenthesis. So in this case, the closing bracket or the closing bracket will always be followed with a hat. And the hat will always be followed with a single digit number. So the single digit number thing is an assumption that the repetitions will only be a single digit number from 2 to 9, because one repetition doesn't make sense. You don't need to add one repetition. It is automatically implied. If you just remove this, that is the same as one rep, and then 0 repetition doesn't make sense. So your the repetitions will always be a number from 2 to 9, and it will always, the closing bracket will always be followed by a hat, because if there is no hat, then there is no need to put brackets in the first place. You can just write it this way. Okay, so yeah, this is something that you should have noticed. Then what you can do is, once okay, let me take a complicated example first. So you have a b c square b c b c a 4 CD 9. Okay, this is complex enough, I guess. So let's say you want to solve for this string. Now there are too many brackets and too much going on here. Let me just make it more tough. So let me say that there are 2 more letters over here. So first thing you should notice is that, like, you should know which bracket is closing where. So this guy is closing here, this guy is closing here, this guy closes here, and this guy closes here. Okay, so let's just say I have this thing called pairs, which is a vector of vectors. Storing the pairs of brackets, in bracket indices. So for this example, this is 0, 1, 2, 3. Okay, never mind. Fine. So I'll just write the important one. So this is at index 0, this is 1, then this is at index 2, then this is at index 3, 4, 5, this is 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay, I think that's right. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18, 19, 20, 21, 22, 23. Okay. So what I have written over here are the indexes of the parentheses. Alright, and then inside my pairs I'll have this. Pairs will be 0, 23, then 2, 5. The order, it can be in any order. You just need to match 0 to 23, 2 to 5, 9 to 17, and 11 to 13. So 9, 17, and 11, 13. So you got all of these pairs. Okay, now how do you use them? Okay. Okay, you actually don't need this. Okay, so now see that if you have only the part inside 0 and 23, which is from 1 to 22, like this string would be this. Get rid of this, get rid of this, get rid of this. Okay, so the part from 1 to 22 will just be this string. Let's say you can solve this recursively. Okay, and then what you get after solving this recursively is the whole string for this particular guy. You get some string s. Now you just repeat s 9 times, times 9, that is bad, times 9, and then you just add a b to this and you'll get your answer. Do you get this? If you can solve this part recursively, then you can just multiply, like add this string 9 times, concatenate it 9 times, and then at the end add a b, and then you'll get your the whole answer that you wanted. Okay, similarly for this particular guy, look at this part here. Like if you look at the index from 3 to 4, this is just BC. So I will make something here, and then look at this part here from 10 to 16. So this will be BC, and this will be BA4C. Now you solve these recursively as well. Okay, so I will take this part over here. Let's say I call this guy S1 and I call this guy S2. So then your final answer for this recursive call, so this is a recursive call because it stemmed from this whole string, right? So that's why I'm saying the answer for this call would be A plus S1 times 2 plus B plus S2 times 3 plus CDA. You see this? So once you solve the part inside the brackets recursively, then you just need to concatenate those strings, the number of repetition times, and then concatenate it with the rest of the string that is left out. Okay, even inside S2 there will be one recursive call for this A. So this guy will have its own recursive call, which will just be A. And then S2 will be B, then this guy will return A. That A will get concatenated 4 times, and then you will add a C at the end to get your final answer. So this is the base case will always have a simple string which has no parenthesis at all. So that is something you can solve directly. So that is the idea for this. This pairs is required for you to identify. So okay, now I'll tell you why the pairs thing is required. So let me. So your algorithm will go as follows. Given a string with parenthesis and the pairs vector, iterate over. So similar to the base case that you had, let me copy this part. Okay, this part says the same. If the character is a letter, append it to your answer. If the current character is this, then you yeah, this is fine. Now you have your, if the current character is an open bracket, then using the pairs vector, find out the corresponding closing bracket with this opening bracket. So let's say str of I is equal to an open bracket, then search for a pair having I as the first element, okay, and get the second element. which is the index of the closing bracket. Call it j for now. So strj is equal to the closing bracket corresponding to I. Okay, so let's say you found j using this pairs vector corresponding to I. Now what you'll do is solve get the string corresponding to the regex from stri+1 to strj-1 recursively. So as I said, the part inside the bracket can be solved recursively, right? So that is what you're doing. You're calling the function from i+1 to j-1, and you get the answer for that. You get the string for that. Call it str2. Then what you do is repeat str2 strj plus 2 times. So you remember strj was just closing bracket as I have written here. So strj plus 1 will have to be a hat, because that is what I had explained here, that okay, I removed it. Oh no, yeah, the closing bracket will always be followed by a hat, and the hat will always be followed by a single digit number. So strj plus 1 will be a hat, and then strj plus 2 will be a number, which is the number of repetitions. So that is why you repeat str to j plus 2 times, and then you concat this str2 into answer and continue with the for loop. Oh no, wait. Make I equal to j plus 2. So now that you have let me take this case. So after you have done BC, the part for this guy recursively, you should set I over here, because I was over here right now. So you have finished out this whole part, so you set I to here, I to 2, and then your for loop will increment I on its own, and then it will start the execution from here. You don't want to do execution for this part in between here, because that is done by the recursive call. That is why you set I to j plus 2, and then continue with the for loop. Oops. Yeah, that is the whole question. I hope that made some sense. I'll show you the code now, which should help you understand it better. Okay, so you have you take str as input, and then you calculate n, which is just the length of the string. Then I create a pairs vector. So the pairs vector that I make is a 2D matrix. So okay, assume that this is a matrix for now. So pairs, okay, this is too big. Let me make it small. Okay, this is good enough. So pairs is a 2 cross n matrix. The first row stores all the opening bracket indices, and the second row stores all the closing bracket indices. So let's say your pairs vector was this. So in this case you'll have 0 over here, 23 here, then you'll have 2 here, 5 here, then you'll have 9 here, 17 here, 11 here, 13 here, and then all of these are not required. So the length, so this array will be a 2 cross 4. That's it. This matrix will be 2 cross 4, my bad. Pairs 0 I gives you the ith opening. I mean, there's no order as such, so just pair 0 and something over here. This will give you the opening bracket thing, and then pairs 1 something will give you the closing brackets. Okay. Alright, so that is how I made the pairs vector. And then to fill up the pairs vector, you have to write some code. I'll explain this in a while. For now, let's look at the recursion. So the recursive function takes in the whole string. It takes in the starting index. So recurse has, let me copy this. Okay, so this is the whole string, the thing that you have to solve. It is the whole string, not the substring. L and R give you the places at which you have to start, like start and end the parsing of this string. So let's say you had A, B, 3, C. So in this case, the starting guy will have L as 0 and C as 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Yeah, so L will be 0 and R will be 6 for the whole thing. But when you're solving this in a recursive case for B, at that time L will be 2 and R will also be 2. So that is what these guys are representing. String will always be this whole string. str will always be this whole string. Pairs will store this 2D matrix. Okay, then what you do is you keep answer as an empty string for now, and you see how many pairs are there inside num pairs. I'll tell you why this is required. Then you start iterating from L to R, and whenever you see an open parenthesis, that is when you have to recursively solve the question. So first you find, using the pairs vector, the corresponding closing bracket. So what I do over here is I iterate over the pairs vector and I check if this opening bracket is the one I am at. Right, so what you do is you iterate over the pairs vector and you check that if is this opening bracket the one I am currently looking at, and if it is, then you find the closing bracket corresponding to this and you break out of this. So you break out from here. Actually I should have, okay, never mind. So you just get the index at which this bracket is stored, and then you break out from here, and then you recursively call you recursively get the answer for the string which is inside the brackets. So you pass I plus 1 here, and then I called this thing, what did I call it over here in my solution? Fine, I called it j for now. So this is just j and j minus 1. So I plus 1 to j minus 1, you call the recursion on it, and you get store it into a temp. So I set it str2 over here, but yeah, in my code I've written temp. Let me just make this. Okay, so you get str2, then as I said, you put I as j plus 2. So this was j. Let me make that change. Never mind, I have used j over here. Okay, let it be this way. So you make I as j plus 2, and then your reps will just be str I minus 0. So this j plus 2 is the index of the number that you have. So str I minus 0 will just convert it to an integer, and you store it inside reps. And joiner is your temp string. So you add str2 into joiner, you concatenate str2 into joiner reps number of times, and then finally you concatenate joiner into answer. So yeah, that is the case for when you see an open bracket. Okay, if you only read a character, then you simply add that character into your answer. This is very simple. Now when you see a hat, you first find the previous character, and you find the reps that you have to make for this character. This minus 1 is done because you already added the character once before. And then you have a joiner, and then you just add previous reps number of times into joiner. You increment I because I explained this in the base case. Where did it go? Okay, never mind, I removed it. So you increment I to get the I pointing or indexing the number instead of hat. So right now it is indexing the hat, so you move it ahead and index it to the number, so that the next like when you go move into the for loop over here, I will get incremented once more, and now it will look at the next letter that is there, or the next character that is there, and then you concatenate joiner into answer, and then yeah, that is it. Okay, so now this was one part of it. Now you have to see how do you actually construct this pairs thing. Okay, so to construct the pairs vector or the pairs array, constructing so let's say I am not I'm ignoring characters for now. I'm only looking at no, I'm only looking at brackets for now. So 1 2 1, never mind, I think I can do this. Alright, this is fine. I'm only looking at brackets for now. So the first thing you see is that this particular bracket corresponds to this one, and this bracket corresponds to this one. So each closing bracket corresponds to the nearest opening bracket that it has seen previous to before it. Did that make sense? So this guy matches with this guy because this is already matched over here. So it will match with the earliest or the closest opening bracket that is not matched already. Okay, so to get these pairs, what you have is a for loop from I to n, and then whenever you see that there is a bracket here, an opening bracket, you push this index into an open IDX. So open IDX stores the index of the open brackets. So you will push the index of the opening bracket into this, and now whenever you see a closing bracket, what you do is you get the you get the index at the back of OpenIDX. So unmatched the closest unmatched open bracket will be at the back of this array. You get that index and you push it into pair 0, and then in pairs 1 you push this particular index, the closing guy, and then um, you pop the opening index from OpenIDX because it is matched now. So I'll just write that since the last index is matched, you pop it from the OpenIDX array. So yeah, that is how you construct this pairs vector, and yeah, then you do this whole thing. Okay, yeah, that was it for this question. Question 4 is counting sort. So they have given you some stuff over here, but it is not required for you to solve this question. I'll explain why this is and what they do they mean by stable algorithm. But you don't need to do this for this particular question. So this question is pretty easy. Oh. Okay, never mind. You actually don't need this. Why did I make this? So let's take an example. Let's say you have these numbers. So what you do first is just why is it so small? Find the max of all the numbers. Okay, that was the step 1 that was written in your in this question. So what you do is just find the max of all these numbers, and the max will be 8, right? Then what they say is to create a count array of size max plus 1. So for this you will create an array of size 9, then you simply count the occurrences of each number. So for this particular thing, your count array would look something like this. Zero, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay. 1, 2, 3, 4, 5, 6, 7. Okay, fine. So this is a array of size 9, and you will store 0 here because 0 does not appear in this array. You will store 1 here, you will store 2 here because 2 appears twice, and then 3 also appears twice. 2. 4 appears once. Okay. Then 5 appears 0 times, 6 appears 0 times, 7 appears 0 times, and 8 appears once. So this is 0, 1, 2, 3, 4, 5, 6, 7, and 8. Okay, ignore the full stops for now. right? So these are the indices and these are the counts of each number, how many times it is appearing. After you have gotten this, you just iterate over this array. So you just iterate over this one by one, and you repeat, you print out one number of times. Then you print out 2 twice, you print out 3 twice, print out 4 once, print out 5 0 times, print out 6 0 times, print out 7 0 times, print out 8 once. And whatever you print out, that will be the sorted array, because you are looking at numbers in this order, right? You're going from here to here and they are increasing. So the final thing that you will print will be in sorted form, and it will print the array in the sorted order. So that is all you had to do. um, Counting sort. So I have a vector called nums. My max value set to -1 for now, and then I set it as -1 because nums can never be negative, so max value will become a0. So whenever you num 0, so whenever you read the first digit, at that time max value will be -1. Nums I will be some number bigger than 0, because you're only taking positive numbers, I guess. So max value will become nums 0 after the first iteration, and then after that you will just keep on taking the max value as normal. So yeah, that is why I've set it to -1. And then you just calculate max while you're inputting numbers from the user, and then you create a vector of counts which has size max value +1, and then for each of them you just add up the counts, and after that you iterate over each of the elements one by one, and you print out I counts I number of times. So whatever is the count, so you print one times, right? So yeah, that is what you do, and then at the end you just print out a new line. That was it for this question. What they have written here, like this process gives you a stable sorting algorithm. So what a stable sorting algorithm is, that if you have two twos here, you would want to ideally maintain that this 2 comes before this 2, and this 3 comes before this 3, even after you have sorted it. So after sorting you'll get 1 2 2 3 3, right? So you would still want this 2 representing this particular 2, and this 2 representing this 2, this 3 representing this 3, and this 3 representing this 3. Why is this required? Because you don't actually sort numbers in computer science. You can have structures, or you can have other things. Let's say you have an employee table where you have a lot of employees, and you're trying to sort them based on their salary or some other criteria. So you would want to keep the ordering of people with the same salary the same, or you would want to keep the ordering of some other thing, whatever you're comparing, the same for some reason. And to keep that the same, that is why you require this particular method. But for this question, you don't really need to maintain like this 2. For you, both these 2's are the same. There is no difference in both of these 2's, and both of these 3's are the same as well. So for this particular question, you don't require maintaining a partial order or an order between elements which have the same value, but it is required in some other cases, and that is why this method is done, and it is called a stable sorting algorithm, which means it preserves the order of equal elements. So that's all. You don't need to do this, by the way. This works for you, I guess. Yeah, that was all for this question. This will be question 5. Okay. So now we have subsets. In this, you are given an array, and you have to create all the subsets corresponding to this array. So you have to solve this using recursion. Okay, so let's say you have 1 2 3 for now, right? So let's just say that I find all the subsets excluding the last number. So I'll exclude the last number and I'll find all the subsets for this. So the subsets for this would be an empty vector 1, 2 and 3. Not 3, my bad, 1, 2. Now what you do is you get this from the recursive solution of this guy. Okay, and then what you do is in this guy you in each of the subset you just add a 3. So you'll have 3 here, then you'll have 1 3 here, you'll have 2 3 here, and you'll have 1 2 3 here. Let's call this what have I written in my code? I've called it includes num for now. So includes num by this name I mean like it includes the last number that you excluded before. So this is a vector, this is a subset, this is a power set that you make, which contain is not a power set, my bad. This is a vector of sets that you make, which contains 3 in all of, like you iterate over all of these guys and you put a 3 in every one of them, and now your answer for this for 1 2 3 will just be the answer for 1 2 plus includes num that you will construct from the answer of 1 2. So what I'm saying is that you take this guy and you take this includes num and you add them or you join them together basically. So you push back everything that was inside includes num into this vector, and now this is your answer for 1 2 3. This is the power set for the whole thing. Okay, this is your answer for 1 2 3. So the base case would be when, so I'll just do a trace of how 1 2 3 will be evaluated. So when you call your function for 1 2 3, the first thing that you'll do is you'll exclude 3 and you will call it on 1 2. Then when you call it on 1 2, this guy will exclude 2 and call it on 1. When you call it on 1, it will exclude 1 and call it on nothing. So this is your base case. Base case is when the nums vector is empty. So in this case, simply push the empty set into the answer. So this whole thing, this whole vector, I am calling it an answer, and it contains all these sets one by one. So you push the empty set into answer. This is your base case. So when you return back for the one case, you will have an empty set into answer. So your answer will be an empty set, and then includes num will become 1 here, because you add 1 into this empty set and you add all sets from includes num to answer. So answer will now become an empty set and 1, and return this to 2, so 1 2. So then you will come at 1 2. Now your answer, let me remove this. Now your answer would be this, and your includes num now will become empty, 2 and 1 2. Now again add all sets from includes num to answer, and now your answer will become all of this and all of this as well, and then you return this to 1 2 3, right? So then I will remove this, and now the final thing I explained over here, your includes num will now include 3 in every one of these, and then you'll add all of those into answer, and you'll return that particular answer vector. So that is how you have to solve this question. I'll just show you the code now. So you have a vector called nums. You take all the numbers as input into nums, and then you have this thing called a power set. So the power set will store all the subsets, and then I call this function recursively with nums and the power set. The power set is, by the way, passed by reference because it is getting modified. Like every single recursive call is modifying answer, right? That's why it's passed by reference. And then at the end I just print out all the sets from the power set. If the set is empty, I continue. Otherwise I can print out all the numbers in this particular set. By the way, this set dot empty is just the same as checking set dot size equals 0, and this set isn't an actual set, it's just a vector with the name as set. Okay, so it is not an actual set, it is just a vector. So the vector has a function called empty, which will return a boolean value telling you whether the size is 0 or not. So instead of writing this whole thing, you can just do dot empty. Okay, so let's look at the recursive function. So the base case, as I said, that if your nums vector is empty, then you push an empty vector into your answer and then you return. If it is not empty, then you take the last element of your nums and store it in num, and you pop the last element. Then you recursively find the answer for all the other guys, for the rest of the numbers, and then you have this vector called includes num, and then for every set inside your answer you will push back the set which contains num. So you will push back num inside set, and then you will push this set into includes num. So you will you are iterating over each of these sets one by one. In all of these you push back 3. So you'll push 3 here, you'll push 3 here, you'll push 3 here, you'll push 3 here. I mean, you're not exactly pushing 3 in these, you make copies of these. So you make copies of these sets. So you have this, you have this, you have this, and this. So when you write a for loop this way, right, this set is a copy of the set that is inside answer. It is not the exact set. It is not a reference to the set that is inside answer. It is a copied version of this set, and then inside this copied version you add 3. So you add 3 in all of these, 3 3 3 3, and then you add all these sets into includes num, and then finally you add all the sets in includes num to answer. The reason why you cannot directly put these inside answer is because you are iterating over answer, and while iterating over answer, if you are adding in new sets into this, you will run into an infinite loop, because you will just keep on adding more and more and more sets. That is why includes num is made, and then all the sets inside includes num are pushed into answer again, and then you print it out finally. Yeah, that was all for this question. So the interleaved string and what was the other one? Interleaved sorted string. Oops, why is this not opening? Anyways, the interleaved string and the interleaved sorted string, they both have the same solution, and the same solution would work for both of them. So yeah, in this question, you only have a sorted, like all the strings. I mean, these two strings are sorted, and over here nothing is sorted as such. So that's the only difference. So you have A B C here and you have A C B here, but my solution would work for both of them. So yeah, I'll explain both of them simultaneously. So let's take this example. Right, so you have these letters and you want to see if this particular string can be formed by taking letters from these two strings. That's what the question is. So you'll have two pointers or two you don't need pointers for this as well. You just need integers to store the index, like which index are you on currently, and then there will be one other index called k for this guy. Now you'll check which one of I and j is matching with k. So you can have four cases. So the first case is none match. Let me call this str1, this is str2, and this is str3. str1i is not equal to str3k, and str2j is not equal to str3k. Right, so in this case none of the letters from str, like not a is not matching with a. Let me change this for now. Let me make this L. So a does not match with L and D also doesn't match with L. So in this case you will simply return false from your function. I'm trying to build up a recursive solution one by one. So this is the case when these letters are not matching. So this can never, L can never, like str3 can never be formed from string 1 and string 2. That is why you will simply return false whenever this happens. Okay. Then you have the case where str1 matches, which was the case before this. Over here A and A match, but D and A don't match. So in this case str1i equals, I'll just copy this, and str2 doesn't match. In this case you can recursively, forget recursion for now, you can do I plus 1 and k plus 1, k plus plus and I plus plus, keeping j same. So what you'll do now is, okay, you're like, fine, I have matched A now, so I will now move on and try to match B. So you'll move this guy, D, my bad. So you'll have K here, and now your I will move onto C. Your D remains as it is because you matched string 1, right? Now you have the case that str2 matches. So you have this case. Now here you can just do the same but with j, like you will increment j but keep I the same. So now your k will go ahead to C and your j will also go ahead to E. Right, this is pointing to E now and this is at C as it is. This doesn't change. And then you'll keep on going until there's one more case by the way, but I'll just tell you the base case and keep on going until k, I and j all reach end of strings simultaneously. All reach end of strings, not simultaneously. And when this happens, you can return true, saying that all the strings have been, both the strings have been interleaved. Correctly. Okay, so when you reach the end of, so okay, never mind, I'll just move it. When k will reach here and then when j will reach here after f and when I will reach here, that is when you can stop. Like you're like, okay, I got this and now you can stop doing this, right? But as you see, there is one more case remaining, which is that a case where both match. And this is where the recursion is required. So you have both of them are matching. So now which one to select? This is not you cannot directly see which one to select, like should I match with str1 or should I match with str2. If you were to select str1 by default, it will fail in some cases, like there is one example in this question. Okay, it's not here, never mind, it is there on both the tree, you can go and look at it. So there is one example where it fails. So I think it was something like AAB and AXY, and your example was AAXBY or something. AY, yeah, I think it was something like this. So in this case, if you were to always select string 1, then you will select the first two A's from here, which will match with here, and then this X will remain unmatched because your J is pointing to A still and your I is pointing to B now, and your K is at X, so this will return a false. But if you selected one A from string 2 and the other A from string 1, then it would give you true. So which one to select from? Like, do I select from string 1 or string 2? And recursion says try out both. So you try doing I++ and K++, keeping J same, and you try doing J++ and K++, keeping I same, and take the or logical or of both cases as the answer. So let's say like this gave you true, like this says that these can be interleaved, but this says that it can't be interleaved. So you will say like, okay, I can take string 1 and interleave it, so I'll do it this way. If this gives you true and this gives you false, then you'll be like, okay, I can pick a from string 2 and get them interleaved. If both of them return true, then it's fine, like anything works. And if both of them return false, which means that no matter which letter I select, either from string 1 or string 2, it cannot be interleaved. So that's why you take the logical or of both the cases, and that will give you the answer. So yeah, that was it for the explanation. I'll show you the code. Okay, so you have three strings, you take them as input, and then you have this function recurse, which takes in the three strings and ijk, which are the indices of each of the strings, like how much of the string have you seen until now. So at the start, all of them are set to 0. Fine. So if I is equal to s1 dot size and j is equal to s2 dot size and k is equal to s3 dot size, which means this is the base case that I explained here, that if all of them reach the end of strings, then you can return true, saying that they interleaved correctly. So that is what happens, you return true from here. Otherwise, you create these three bools a, b, c to store whether I is less than s1 dot size, j is less than s2 dot size, and k is less than s3 dot size. So before you actually index into s1 and s2, you might actually run into errors here, because if I is equal to s1 dot size and you do s of I, then you're trying to access something which is out of bounds, which is not which will give you an error. So to avoid those errors, you just check whether these conditions are satisfied first, and then do the array indexing. And because of the property of AND operators, if one of these is false, you will not check the rest of them, you will short circuit out and move on to the next else if block here. Alright, so yeah, that's why you check whether these booleans are true or not. And then okay, this should have been C here, my bad. You check if all of these are true, and then so this is the case when s1 is also matching and s2 is also matching. So if both of them are matching, so as I said, you will try out both the cases and take the OR of both the cases. So that is what I've done. In this case, I increment I by 1 and increment k by 1, saying that I match the current letter with string 1, and then I'll see what happens. And then this is when I match it with string 2, and then I see what happens, and then I take the OR of both of these cases and then return the answer. If only string 1 matches, then it is simple, you only do I plus 1 and k plus 1. If only string 2 matches, then you do j plus 1 and k plus 1, and if neither of them match, then you return a false. Yeah, that's it for this question. Okay, now we have the longest sequential job chain question, and it is similar to sort jobs, so I'll explain them side by side. So in this, you are given n jobs and you have to schedule them such that you get the longest job sequence. Like you want to schedule the most amount of jobs that you can. So finding out how to solve this is not very trivial. It will take you some decent mathematics and computer science to figure out how to solve this. So it should be given in this question on how to solve, then you can try to code it up. So the way to solve it is to sort the jobs into ascending order of ending times. So you will try to sort them into ascending order of ending times, and then you can start selecting jobs one by one, and that will give you the longest job sequence that you can get. Now, why does this work? How does this work? It will require a big mathematical proof, and that can be skipped for now. It will not be easy for you to understand. So yeah, you can. So you just have to sort these jobs in ascending order of ending times, and then um, pick out the jobs that can be done together. So for example, I'll show you this part of the code. So let's say like you sort the jobs somehow, as I said, with ending times, and then what you do is you take the last end. So last end will store what was the last job that I saw, which I have scheduled, and uska what is the last end. So let's say in this example, this is in sort. This is not in sorted order. Wait, let me show you what is the sorted order for this. I remove this for now. Okay, so this is the sorted order for this. You'll have 1 3, then 3 5, 5 7, 5 8, 7 9, 6 10. These are sorted by the ending times. Okay, so first you will schedule this guy. So now your last end over here, your last end will become 3, because 3 was the last scheduled job's ending time. Now what you'll see is you will look for the next job which has the starting time to be greater than or equal to the previous guy's ending time. Alright, so this guy satisfies it. So 3 is greater than equal to 3. So now you can schedule this job, and now your last end will become 5. Then you see this guy also has 5, which is also greater than equal to the last ending time. So now you will schedule this job, and now you have the last ending time as 7. Now you see 7 is bigger than 5, so you cannot schedule this job with this. So you have to skip over this, and you'll go to 7. Now this job can be scheduled with this guy, and then your last scheduled guy, the last ending time will be 9, and 9 is greater than 6, so you cannot schedule this, and so your answer will be 4, which is the answer here. So yeah, that is what you had to do. The main part in this question was to sort them correctly. So let's see how the sorting works now. This is similar, what I have written is a merge sort, and it is similar to what you have done in class. So when you call sort jobs, this function just takes in a vector of vectors. Oh, by the way, before I continue on, jobs is a 2D vector, 2D matrix, which stores so jobs is something like this. Okay, so this is jobs, where each row stores this is the S time. Okay. Start, and this is the end time for each of the job. So this is one job, this is another job, this is another job, and so on. So that is how the jobs are stored. The job ID is useless for this question, it is not useful. In the sort jobs question, you'll have to store the job ID as well, which I'll explain later on. So for this question, the job IDs are not required, so you can just throw this information out. You just need the starting and the ending times for each job, which is stored in this jobs array, jobs matrix. Fine, so you pass this jobs matrix to your sort function. Your sort function just calls merge sort, with the starting L as 0 and ending at jobs.size -1. So 0 will be this, and jobs.size -1 will be this. here. You call merge sort on this. Then your merge sort function is the same, I guess. There's no difference here. So you just take a matrix and you take L and R. If L and R are equal, then you just return. You don't have to do anything because one element is always sorted. One element is sorted. Otherwise, you find the mid. So in our case, mid would be 1, 2, 3, 4, 5, 6. So mid would be here, I guess. 6 divided by 2 gives you 3. Okay, never mind. This would be the mid. Am I doing it right? 0, 1, 2, 3, 4, 5. 5 plus 0. 5 by 2 gives you 2. 0, 1, 2. Okay, never mind. This was correct. This will give you, this is mid. So then you recursively sort jobs from 0 to mid. You do a recursion over here, and then you solve this from this to this recursively, and then you merge both of them, and that is how merge sort works. So let's look at how the merge operation works now. Okay, so the merge operation takes 4 things. One is jobs, second is L, mid and R. So the merge function merges arrays jobs L to jobs mid with jobs mid plus 1 to jobs R, and also stores them in place in the sorted order. So okay, you have this matrix called sorted jobs, which will store the jobs in the sorted order. Like when you do merge sort, right? When you're doing merging, sorted jobs will store all of them in the sorted order. And then okay, so you have J, which starts from mid plus 1, and I, which starts from L. So while I is less than equal to mid and or J is less than equal to R, so until we have elements in either of the arrays or either of the jobs, until there are elements left, you will keep on looping here. So if the first array or the first part is over, like you have exhausted all the elements in the first part, then you simply have to push all the elements from the second array into your sorted jobs matrix. So that's what you do here. You just push all the elements from the second array or the second jobs thing into sorted jobs. If the second part is over, so if J has reached R, then you have to push elements from the first job, that the first part. So that's what happens over here. If both of them are not over, if both of them are having elements, then you have to compare them. So you have to compare the end times. So if the end time of the first part is smaller than the end time of the second part, so you push the first the element from the first part into sorted jobs, and you do I plus plus. Otherwise, this means that the end time of the second part was greater than less than or equal to the first part. So in that case, you just push the element from the second part and you do J plus plus. So this will sort all the jobs from L to R and store them into sorted jobs. But now you want this to be reflected into jobs itself. Like you want all the elements from L to R to be sorted inside jobs itself. That's why you write this and you sort the jobs vector in place. So you replace all the elements from L to R and put them as the corresponding element in sorted jobs. Yeah, so that's all this merge function does. And then you will sort jobs entirely, and then you'll just see ki how many of them can be scheduled together, and print out the number of jobs that can be scheduled together. The sort jobs question is similar to this. The only difference there is that number one, you have to store the when you're printing your output, you are also printing the job IDs. So your jobs vector will now become a 3 n cross 3 vector. So you'll have three things over here. And this whole guy gets a new. Okay, this is the end, this is the start, and now you get a new addition over here. I hope you get the idea. And then this will be storing the job IDs. That is one change that you have. Then the next change that you have is that you are sorting them based on ascending order of the start time. So the previous question was sorting based on the end times, but now you're sorting based on the start times. So over here you will have, since you're also storing the job IDs now, so the 0 index correspond to the job IDs, the 1 index corresponds to the start time, and the second index corresponds to the end time. So you will check which one is smaller in your merge function, and if the first part is smaller, then you will push the first element from the first part. But also there is this case where the start times are equal, which need to be handled. So if the start times of two jobs are equal, then you need to select the one with the smaller end time. That is what is written over here. So if both of their start times are equal, then you check the end times, and if the end time of the first part is smaller than the end time of the second, then you push the first part, otherwise you push the second part. And then again you copy all the elements into jobs again to get the jobs matrix sorted from L to R, and then you keep on repeating this using merge sort, and the rest of the code stays the same almost, and you print the jobs at the end in the format that they asked, like printing them one by one on each line. And yeah, that's the sort jobs question. On to the last question now. So we have this question called connect 4. Okay, so the question says that you have a grid which is m cross n. The cells of the grid can either have R, B, or a dot. A dot is an empty cell, and it says that you need to find whether the board is in the valid configuration or not. So there are two rules that you need to follow. The first is the number of red discs must be greater than or equal to the blue disc, and they can only exceed by 1. And the second is that the disc must occupy the lowest available position. So you cannot have a disc that is flying around in the board. So let's say this is your board, and you have, let's just copy this. Okay, I think this is good for now, so forget this. So as you see, like all of these are empty, like this is empty, this is not allowed, you cannot have this, because if you put this R here, it would go to the bottom and the R would be situated over here. It cannot be floating around on the board. So that is the gravity rule. Again, this row, this whole column here, it is floating around. There is nothing present on this in this place, which is not allowed. So that is why this is an invalid board. You should have started R from here, and then B over here, and then that's how it should go. So the first row that will be filled is this one, and the second, this row will be filled, then this row will be filled. So yeah, that's the gravity rule. The turn order is very simple. You just need to count the number of reds and the number of blues to find out what is their count, and you have to make sure that number of R's is equal to number of B's, or rather you can just do number of R's minus number of B's should be less than equal to 1. This is something you can make sure. And also and greater, so I'll just write it this way for now, 0. It can't be negative as well. So yeah, this is something you need to make sure. Okay, let me open the code at this side. Okay, so find winner can be ignored for now. Let's just look at is valid. So what you do is you take in n and m, and then you read the board. So you take the board as input, and then you check the gravity and the turn order rule, which are these two rules. And if it is not valid, then you print invalid board, which is what is asked in the question. You have to print invalid board. So you print invalid board and then you return. You don't need to check for the winner. Okay, so what does is valid function do? It first has red count and blue count, which is number of R's and number of B's. And if the current letter is R, then you do red count plus plus, otherwise you do blue count plus plus. And then you check whether red count and blue count are equal, or red count is equal to blue count plus 1. If neither one of this is true, then you return false, which means that the board is not valid. After that, you do the gravity check. So the gravity check is done this way, like for I'll just get rid of this. So the gravity check is done this way. You iterate over each of the columns one by one, and then you see whether this guy is filled or not. I guess that's what is done. You start from, so this is row m minus 1, row m minus 1, and then this is row 0. So you start from the bottom like this, and then you go like up, and then if you find that one of the places is empty, so let's say that this guy over here was empty, there's nothing here, then you set found empty to true. So you'll have a boolean called found empty. So you'll say that in this particular column I have found one entry which is empty. There is nothing placed over here, so no letter can appear on top of this, because if there is some letter appearing on top, then it violates the gravity rule, and that's why the board is invalid. So that's what you check. If you found that there was an empty cell in this column, but the current cell that you are on right now, it is not empty, it is not equal to dot, then you return false. So for this case, when you go over here to R, you will see that you have already found an empty cell in this column, but this particular cell is not empty, so you will return false at this position. Similarly, if this were I have modified this, so this was B. Why am I not able to? Okay, so similarly for this row, for this column, you at the first iteration for row m minus 1, you will find that this is empty, so you will set found empty to true for this guy. And then when you read R, you will see I have already found an empty element, and R cannot be placed here. All of these should be dots as well. Nothing can be placed on top, and so this guy will return a false from here. Yeah. So that's how the gravity rule is checked. And if the whole board was nothing was returned, then you will reach the execution will reach here, and then you will return true from here. Okay, so now for the winning condition, you should have four consecutive discs of the same color in either a row, a column, or a diagonal, and the board is invalid if both players are winning simultaneously. So you check if red is winning and is blue if blue is winning individually, and then if both of them are winning, you will print invalid board. Otherwise, if just one of them is winning, you will print who won the game, and if no one is winning, you will just print no winner. Then we'll see what happens in the check winner function. So the check winner function takes in a board and a player, and then you iterate over all the elements inside the board, and you check each direction individually. You check whether there are four consecutive discs of this player in this direction, in this direction, in this direction, and this direction, and if either one of them is true, you will return a true. Otherwise, if none of them were true, you will return a false from here. So this is what I've explained over here. Oops. Yes, I'll have to. Yeah, that is better. Okay, so let's say you are at this position right now. So what the first function call will do is this one denotes dx and this denotes dy. So it's telling how much are you stepping in the x direction and how much are you stepping in the y direction. So 10 just means that you will step in the x direction over here. I am assuming that this is positive x and this is positive y, because your row indexes start from here 0 1 2 and so on, and your column indexes start from here 0 1 2 and so on. So yeah, doing this, actually x is the column index. Wait, so let me correct this. This is y and this is x for now. So y increases this way and x increases this way, and so the first call 10 would be stepping in this direction over here. So you will check whether there are four consecutive elements here, but they are not. Then 0 1 is stepping in this direction, and 1 1 is stepping in this direction, and 1 minus 1 is stepping in this direction over here. So you are checking these four directions and making sure that if you find four consecutive elements of the same color, then you will return true. Otherwise, you will keep on checking so now then you will move on to the next element and check these four directions, and move to the next element and check these four directions, and so on. So you'll check all the elements from all positions. You'll check these four directions and see if you find consecutive elements. So let's see what the check direction function will do. So it has a loop, so it just checks four elements in that particular direction. To move in that direction, you just do x plus equals dx and y plus equals dy. So for this case, your dx equals 1 and dy also equals 1. So after each iteration in the loop, your x will increment by 1 and your y will increment by 1. So now you will check this, then you will check this, then you will check this, and that's how you will check this direction. So similarly for the other directions as well. Over here you actually check if the coordinates x y are out of bound, or the color doesn't match, i.e. no four consecutive elements of the same color, then you return false. If you were to find four elements in this direction of the same color, then you'll return true, and then this whole thing will become true, because if even one of the directions gives true, then this whole condition will give you true because it's a logical OR. And then you will say that this player is winning in this board, so you will return true from here, and then you'll get true in either red wins or blue wins, depending on who the player was who was winning. And yeah, that's how this code works. So that was all for this question, and this was the last question for lab 9.